Good day to all the lecturers and all my fellow friends. Today I would like to present the project proposal which entitled Modeling and Simulation on Carbon Dioxide Pressure Swing Adsorption. My name is Benjamin, my matric number is 188286 and my supervisor is Professor Thomas. The content of this presentation include the research background, problem statement, objective, and also the methodology. There are 3 key points in this project, which are carbon dioxide, climate change, and pressure swing adsorption. Okay, firstly, I will go into the research background. According to the Y chart, the current carbon dioxide emission in Malaysia is at 251.52 metric tons, up from 242.85 metric tons 1 year ago. Therefore, there is a change of 3.57%. The change is due to the rapid development of country from agricultural to an industrial economy in Malaysia, and therefore accelerating the number of automobiles, factories, and power plants. Besides, according to the Malaysia Biennial Update report to the UNFCCC in 2015, there are 5 major sectors that involve in the greenhouse gases emission. There are energy sector, waste sector, industrial processes, agricultural, land use change, and forestry. Throughout these 5 sectors, energy sector contribute the most greenhouse gases emission, which is 76%. Besides, throughout all these 5 major sectors, carbon dioxide contribute the most percentage in the greenhouse gases, which is 72%, much more than methane and nitrogen oxide. Okay, now I would like to go into the problem statement. Due to the increasing carbon dioxide emission, we all know that it will only worsen the global warming and also sea level rise due to the ice melting and many other consequences will occur. Therefore, the most effective way to reduce the emission is the implementation of carbon capture storage in the country. However, it's only limited to the small-scale research project and still at the embryogenic stage in Malaysia. Hence, it is interested to study and know the effectiveness of the carbon capture model, which in this case is pressure swing adsorption, by simulating the carbon dioxide pressure swing adsorption. Apart from the adsorption, there are also other technologies to reduce the carbon dioxide emissions, which are absorption, cryogenic separation, membranes, and microalgae fixation. However, pressure swing adsorption is commonly used to capture carbon dioxide as it requires low energy and it is cost advantageous, and lastly it is ease of applicable wide range of temperature and pressure. Therefore, now I would like to talk about the pressure swing adsorption. Pressure swing adsorption can be described by the Scarstrom cycle. Scarstrom cycle involves 2 packed adsorbent bags, which shown in the figure on the left. The objective of having these 2 bags is to make sure that the flow is flow in the continuously way and the flow rate is maintained. Besides, the cycle involves 4 primary steps, which are pressurization, adsorption, countercurrent blowdown, and lastly the countercurrent purge, which depicted in the figure on the right hand side. To further describe on this figure, in step 1, bed 1 is pressurized to the higher operating pressure with feed from the feed end, while bed 2 is blown down to the atmospheric pressure in the opposite direction. Then, in step 2, high pressure feed flows through bed 1, where stronger component is retained in the bed, and gas stream enriched in the weaker adsorbed component leave as effluent at a pressure only slightly below that of the feed. A fraction of the effluent stream is withdrawn as product and the rest is used to purge back to at a lower operating pressure. The direction of the purge flow is also opposite to that of the feed flow. Hence, for the step 3 and step 4, step 3 and step 4 follow the same sequence but with the bed interchange from the step 1 and step 2. Okay, now I would like to go to the research objective. In this thesis, a more general model for pressure swing adsorption is developed, such as a non-isothermal pressure swing adsorption model for the separation for carbon dioxide and simulation of the process configuration is developed. The purpose of the thesis are: first one, learn to develop the mathematical model of carbon dioxide pressure swing adsorption. Learn to develop computer program by using MATLAB. And lastly, to predict and simulate the purity of carbon dioxide pressure and temperature profile. And lastly, I would like to talk about the methodology. The methodology is the way that I carried out the final year project. The first step is to identify the pressure swing adsorption modeling aspects and consideration. And second step will be the development of the model equation. And third one will be provide the numerical solution for the models and steps taken to verify the solution. And fourth one will be the discuss on the simulation result obtained from the model. And the last one will be make a summary of and conclusion and also recommendation for the future work. Okay, now I would like to further describe on the first step, which is identify the pressure swing adsorption modeling aspect and consideration. There are 5 aspects that have to be taken to consider. There are adsorption equilibrium, heat effects, pressure characteristic, axial dispersion, and adsorption kinetic. However, in here I just only explain on the pressure characteristic, where the pressure drop across the pressure swing adsorption column can always be neglected. Therefore, the pressure is only related by the linear relationship. And we can see that on the figure on the right top side, during the pressurization step, the pressure is increased linearly and then constant during the adsorption, and then decreased linearly during the blowdown, and also constant during the purging step, which is the last step. Then I would like to also further explain more on the development of the model equation. There are several. Now here will represent the steps that included that must be taken to develop the model equation. The first step will be the make assumption, then followed by the provide the transient overall mass balance, develop the transient component mass balance, then transient heat balance, and also mass transfer rate, adsorption equilibrium isotope, and lastly will be the initial and boundary conditions. Okay, that's all for my presentation, and thank you for borrowing me yours. Thank you.